Hello and welcome to this lecture of mathematical logic part 2. In the previous lecture, I have discussed about the logical connectivities. There are five kind of connectivities and how to make their truth tables. Now we will learn in this lecture how to make truth tables for compound prepositions. I have given a slight idea for what is a preposition or a statement in mathematical logic is. Later I will make a short detailed video I want. So first we have told to make a truth table of P or Q implies P and Q. For making this truth table, we'll first write P and Q. We had true, true, false, false, true, false, true, false. I have discussed this thing also in the previous lecture. Then we'll find the value of P or Q. We know for inclusive or if at least one of the truth value of the preposition is true, then the output will be true. So all these three truth values are true, and they are all both the prepositions are false, root value of both the prepositions are false, so this is becoming false. And for truth table of and, we are again construct truth values of P and Q. We again know for and if both if and only if both the values of the preposition are true, then the values will become true. So by same logic, we have made this truth table. Now for imply, we know that the first truth value or the premise and the it should be true, and and if the final truth value of the conclusion is then second truth value of the conclusion is false, then the output becomes false. So here this case is satisfied in both these cases, so the outputs become false. Otherwise, the truth value becomes true, so this truth values becoming trues. So this is how this truth table is constructed. First, we have taken P and Q two statements, their truth values, all possible truth values combinations. Then we have found out the P part of this truth value of this part, then and this part. Then we combine by the connectivity implies. Similarly, for getting truth value of P implies Q implies P, we first find out the value of P implies Q and Q implies P, then just apply the logic of P implies Q implies Q implies P. So same, we will using the same logics. So similarly, some more truth tables are made. Say Q implies negative P, negation of P, double implies or biconditional, P implies biconditional Q. We know first taken the truth values of P and Q, that the negation of P gives the opposite values, so true becomes false, true becomes false, false becomes true, false becomes true. Then simply use the implies logic for this two. This given P implies Q. We use the double implies logic on P and Q, get this one, and then you apply double implies logic again on this. We know what double implies is same as negation of exclusive or. We have discussed in this previous lecture. Now, similarly, we have just made some more truth tables. As you can see, this is very simple. So this is a short lecture. In next lecture, I will be talking about what is the preposition statements and preposition in a mathematical logic, and maybe the DNF and CNF parts. So thanks for watching.